All right, so today and tomorrow we're going to be looking at a specific case of the law of sines. So our biggest focus today is what happens when we're given two sides and a non-included angle. So for instance, when I look at this picture, suppose I know this angle A, and then let's say I know side B and side A. So we have angle, side, angle, right? And as I've heard geometry teachers say, there's no ass in geometry, right? We cannot use angle, side, or side, angle to prove congruency, and we're actually going to talk about why here as we go through our lesson. So when we see this, when we have an angle and two sides, but not the two sides around the angle, we have to be very careful. So we're going to talk about today that the fact that when you have angle, side, one of three things is going to happen. Either no triangle can be created, one triangle can be created, or, and more interesting for us today, is that two unique triangles exist. And when that happens, it's called the ambiguous case, because if we're given this information and asked to solve a triangle, the question is, well, there's two triangles, which one are we talking about? Okay, so we think of it as the bad word, the bad situation, because it causes a little bit of extra thought on our part, maybe a little bit of extra work on our part. All right, so here's the thing. If we're given angle, side, let's talk about the angle that we're given. That given angle is either going to be acute or obtuse. Because if it's 90 degrees, we are not using the law of sines. We're using Pythagorean theorem, SOHCAHTOA, okay? So we're going to start with the geometry kind of case, which is the obtuse angle. If the one angle that you're given is obtuse, we either have 0 or 1 solution. And here's the thing. I mean, makes sense to us. The side across from that obtuse angle has to be the biggest side. We already know that. So let's draw some pictures. It says determine if a triangle can be formed. So we have angle, side. I'm going to draw a picture. That is an obtuse angle, so I'm going to make it look like one. I'm not asking you to get out protractors and rulers, but we're just going to draw. Okay, so there's my obtuse angle. That's angle B, which means side B has to go across from it. The only other piece of information I have is the other side, and that can go here or here. I typically put it here. I go around and say angle, side. And so geometrically, we're going, oh yeah, remember, the biggest side is across from the biggest angle. So of the two sides I have, good thing, the bigger side is across from that angle. So the answer is yes, a triangle can be formed, and that's because the bigger of the two sides is across from the biggest angle. Now we go down to the next one. I have another obtuse angle, 135 degrees. We're calling that angle C, which means side C has to go across from that. Side B I'm going to put here. Look, they're telling us B is 6, and if C is 3, I'm going to have a really hard time forming a triangle because I've got to get all the way down here, right? So it's too short. So the good news is, you know, whether you have a picture or not, or maybe you're like, oh, I don't know. It's mathematically, you don't have to do anything. You're just going to look at it, and you're going to ask, is the bigger side across from the bigger angle? And the answer here is no. Here it is, yes. Now, maybe you forgot to look at this. Maybe you forgot to ask this question. Here's what we can also do. We can say the sine of 135 degrees over its opposite side equals the sine of angle B over its opposite side, which is 6. And we could start solving this. I'm making sure my calculator is in degrees. And so I could just start solving. I'm going to multiply that 6 to the other side. So I have 6 times the sine of 135, and I'm going to divide that by 3. And so right now I have the sine of B is equal to 1.4142. When I go to take the inverse sine of that number, my calculator gives me an error. It's saying, no, you can't do that. Well, I should have known that from the beginning. Whether or not I had the picture, I shouldn't say from the beginning. I can know it from here. the sine graph only goes as high as 1. So if I'm asking when is the sine graph equal to 1.4, that's never going to happen. Okay? So I think geometrically we can understand if we're going to have 0 or 1, but if you forget and you start doing the math, your calculator will tell you when there's no solution. Okay? All right. So let's take a look at the case where the given angle is acute, because in this case we're either going to have 0, 1, or 2 unique triangles. And so here's what we're going to do. This is how I draw all of these. When I realize I have angle side side, I'm going to start by putting that given angle in that bottom left-hand corner. And I drew this dashed line here instead of a solid line because, okay, sorry about that. So what I'm going to do is I'm going to take the angle that they gave me. Again, we'll talk more about this in a little bit. And then the other two sides, those are solid lines because those will be given to us. So I'm just going to call that side 1 and side 2. So again, we're going to be given angle side side. I am going to, and you'll see why, I'm going to call this side the gate. So the gate is this side that's kind of hanging from this pivot point. And what I'm going to do is I'm going to show you these 3 cases and what's going on. So case number 1. When I write the gate is too short, it's going to create 0 triangles for us. So I'm going to pull this calculator over and I'm going to take these numbers here. So I want angle A to be 40, and you know what, that's close enough. I want side A to be 4, and I want side B to be 8. And so you kind of notice it's the exact same picture that's on our previous slide, right? And I'm calling this side the gate because what I'm about to do is I want to create a triangle, right? But right now I don't have a closed figure. So I'm going to grab this point here. I'm just going to start moving it. And as that gate swings, I realize, oh my gosh, it's too short. It's not going to ever close the triangle. It's not going to hit the ground. I call this one the ground, right? So this gate is just kind of like hanging there, like swinging like the gate of a fence, and has nothing to attach to. So that's the case where we have no solutions. So what we're going to do is we're going to kind of draw that on our paper, right? So we've got our ground. We've got our 40 degrees. There's my angle A. We said side B is 8. And then we said side A is half of that with a 4. Right, so again, I just drew that side because I didn't know how long that side was. They didn't tell us how long this side was. But even if you want to kind of draw a picture here, kind of like say, hey, we swung this side to side, it's too short. Now, I mean, we had this calculator here. It gave us really nice pictures and exact values. How are we going to know that there's no triangles without drawing and measuring, protractors, rulers? Well, just like in the slide above, we'll start doing the math, right? So I can say the sine of 40 over 4 equals the sine of, let's see, if this is side B, this would be angle B. And I'm going to grab my calculator again. I'm going to multiply that 8 to the other side. And so I have, clear this out, I have 8 times the sine of 40 divided by 4, and that gives me 1.286. And I can get it from there, or I can go ahead and say, let's find the inverse sine of that answer. And oh, look at that, error, no solution. So the calculator tells us that there's a problem, right? Again, I kind of see it from here. This number is bigger than 1, so I know that there's no solution. Okay. All right, let's talk about our third case. When we have one triangle, when the gate is the longer of the two sides. So again, I'm going to grab this demonstration again. A is still 40, A is still 4, but now I want side B. I'm going to just change it here. Whoops, see if we can't change that. Perfect. We're going to make B 3. Okay, so I made my triangle really small, but that's okay. So I'm going to take point B again, and I'm going to swing it because it's the gate. It's the one that's movable. And when I bring it down to the ground, look at that, I've just created a triangle. If I keep swinging it, now it's just there. Okay, well, that's it. So there's one triangle because the gate cannot swing in, and I know that doesn't make a lot of sense right now until we do the next one. but the gate is the longer side. So I'm going to move that and let's go draw it. Maybe I'll draw it a little bit of an exaggeration here. So we've got our ground, we've got our 40-degree angle. We've said B is 3 now. I know it looks like the same size when I drew it was 8. And this side needs to be longer than that, so I'm going to really exaggerate it over here. Right, and it's going to hit the ground way over here. So the gate is the longer of the two sides, one triangle. That's the case I've been giving you for the last few days when we use the law of sines because it didn't create any problems. Okay? All right. So let's talk about this case. This is called the ambiguous case. Let's write that down. And what's happening here? Let's go back to the calculator. What does it mean when I say the gate can swing? So A is still 40, A is still 4, the side A, and now I want B to be 5.5. Okay, so kind of like back where we were on the front. So I'm going to take point B again, and I'm going to swing it, and then look at that. There, it hits the ground, and there's a triangle. I'll draw that in just a minute. But if I keep swinging that gate, it hooks onto the ground again in here, creating another triangle. So I'm out here, so down and to the right, or the gate can swing in and form another triangle. The gate came down and to the left. That's the ambiguous case. Given these three numbers, we can create two unique, that means different, triangles. So I'm going to kind of draw what we have here. Here's the ground. Here's my 40-degree angle. Let's see, this side is 5.5 and my gate is 4. I'm going to use red for my gate here. All right, so from the pivot point, the gate either went down and to the right and hit the ground, or it swung in and hit the ground about here. The length is still 4 though, right? That's not changing. I just have two different triangles. Now I kind of made a mess of my first triangle, so maybe I'll grab a highlighter here. So triangle number 1, triangle number 2. Notice here, I didn't use all of this, right? Because when I swung it in, now I don't need this. This side C, is now much shorter. In fact, everything's different except for the 3 pieces of information they gave us. Let's label those. We've got angle A, side A, side B, so angle B, which means this would be most likely angle C. Okay. So the big question then is, okay, if the gate is shorter than the other side, right, like here, the gate is shorter, how do I know when it's too short versus going to give me 2 triangles? Well, that's when we do the math. If your calculator says no solution, then you know there's no triangles. If the gate is the shorter side and your calculator spits out an answer, that's when we're going to have 2 triangles. We're going to summarize all this on our last slide in a minute. All right, so let's not answer this first. Let's go up here and let's start solving. Let's pretend we don't know which triangle we're in. But what we can use is the law of sines. So I've got the sine of 40 degrees over 4 equals the sine of angle B over 5.5. And I'm going to multiply that 5.5 to the other side and then take the inverse sine of all of that. And that's where I'm going to grab my calculator. All right, here we go. I've got the inverse sine of 5.5 times the sine of 40 degrees all over 4. Whoops. Okay, now for our conversation purposes, let's round that to the nearest whole number. So let's call that 62 degrees. Now that's angle B. So let's look at our pictures. Angle B is either this one or this one. And I'm looking at these pictures going, oh, well, I think it gave me the one, it's the acute angle, right? So angle B in this picture is 62 degrees. I want to find angle B in this picture, which is an obtuse angle. I'm going to come back over here and let's just use this picture. If this is 4, and when I swung it in, it would also be a 4, that means this is an isosceles triangle. And if this base angle is 62, then this base angle is 62, but I'm trying to find this one. So we would do 180 minus 62 degrees. I mean, listen, we know that sine is positive in quadrants 1 and 2, so I'm really going to look for the other angle in the second quadrant, right? So the calculator spit out the answer in the first quadrant. We know sine will give us another answer in the second quadrant, right? We're just saying, what's the name of that angle? So it's 180 minus 62. So it's going to be 180 minus the first answer that we get every time. Okay. All right. So let's take a look here. It says determine how many triangles can be formed with the given measurements. All right, so let's draw a picture. We have angle F, side F, and side G. So angle F is acute. Might draw it to scale a little bit, 60-ish degrees. It's angle F. Side F is 9 and side G is 10. So here's the gate, and the gate is shorter. Let's write that down. The gate is shorter. And when the gate is shorter, we either have 0 triangles or 2 triangles. How are we going to know? We're going to have to start the math, right? So I'm going to say the sine of 61 over 9 equals the sine of, let's see if that's side G, that would be angle G over 10. So we're going to have to do a little bit of the math. We'll multiply that 10 to the other side. And so I'm going to go grab my calculator. You can either take the inverse of both sides, or you can just start typing it in, sorry. I have 10 times the sine of 61 divided by 9. So I have the sine of G equals 0.972. We can go ahead and find it. And it gave us an answer, right? And so because we had 0 or 2, and the calculator spit out an answer, we know that this is 2 unique triangles. Good, let's look at this one. Same angle F, so let's go ahead and draw it a little bit to scale. 61 degrees. Let's see, F is 6.2 and G is still 10. So again, the gate is shorter, so that means either 0 or 2, and we're going to need to start the math. I'm going to say the sine of 61 over 6.2 equals the sine of G over 10. And so I'm going to grab my calculator and I'm going to type in the inverse sine of 10 times the sine of 61 all over 6.2. And look at that, it spits out an error. And because it spit out an error, I know that there are 0 triangles, not 2. Okay. All right, so let's just kind of organize all of this information because it feels like a lot. So here's the thing, but this flowchart only works when we're talking about angle, side, side, when you're given an angle and 2 sides following. If your given angle is obtuse, to me that's the easier one to see. If your given angle is obtuse, you're asking, is the longer side across from the obtuse angle? And if yes, the answer is 1 triangle. if the shorter side is opposite of the obtuse angle, then you have 0 triangles. Also, though, in this case, the calculator will give an error. Okay. All right. Let's talk about this situation over here. This is where we spent most of our time today. So when you're talking about an acute angle that's given, I'm going to start talking about the gate. I'm going to say, is the gate the longer side? And if it is, you have exactly 1 triangle. If the gate is the shorter of the 2 sides, you either have 0 or 2 triangles. And how are we going to know? You're going to have to do the math. So I'm going to say start the math or do the math. And by math, I mean the law of sines. And see if you get an error, right? If the calculator gives you an error, you have 0 triangles.